AI technology architecture. This is part of AI Enterprise Architecture series. This is part 4. We'll cover technology architecture in this video. The agenda is as shown earlier with very specific focus on the third chapter here. As part of the AI technology architecture, this is the agenda. Welcome again. This is your host, Savit Vittal Salian. Namaskar. If AI infrastructure architecture provides the raw horsepower, which is the compute, the storages, the networking, then AI technology architecture provides the toolkit and middleware that harnesses this power to design, train, deploy, and manage the AI model. It encompasses AI development frameworks and libraries, middleware and APIs for interoperability, MLOps platforms for lifecycle management, emerging paradigms such as foundational models and AI agents. So, when infrastructure answers what hardware runs AI, technology architecture answers what software and platforms build and operate AI. AI technology architecture is not about algorithms and code. It is the enterprise toolkit for harnessing AI safety and at scale. It provides the platform, the middleware, and orchestration capabilities needed to design, train, deploy, and govern the AI models consistently across the organization. This means that AI is not being built in silos or as one off experiments, but through a structured foundation that ensures efficiency, security, compliance, and scalability. In practical terms, it is the layer that transforms raw AI innovation into reliable business outcome while embedding the necessary controls to protect reputation, manage risk, and ensure regulatory alignment. So if AI infrastructure as an analogy is the kitchen, which is the physical space, the stoves, the fridge, then AI technology architecture is the cooking tools and methods you use inside a kitchen. Let's understand this better. It includes softwares, frameworks, tools, and platforms that let you build, train, deploy, and manage AI systems. The key elements include AI frameworks, APIs and middleware, MLOps tools, and automation and scaling tools. Tools like TensorFlow or PyTorch, like the cooking technique of baking, frying, and steaming, are part of the AI frameworks. Bridges that let the AI talk to other systems are the APIs and the middleware. These are like the waiters delivering the food between the kitchen and the dining halls. For automating model training, for deployment and monitoring, you have MLOps tools. These are like your kitchen appliances, the mixer, the ovens with timers. Kubernetes, ML flows, Ray are your automation and scaling tools. It's like having kitchen assistant who speed up things. So from a framework perspective, if you look at the analogy, the cooking technique are your frameworks. The waiters are your APIs and middleware. Your kitchen appliances are your ML tools ops. Your extra kitchen staff are your automation and scaling aspect. You go deeper into this. The baking, the frying, the grilling, each fits a different dish. Similarly, in AI, TensorFlow or PyTorch are chosen based on the project needs. When it comes to API and middleware, they are the API connects models to apps like chatbots or fraud detection systems. It's like from a kitchen perspective, they carry the food from the kitchen to the dining hall. They are the waiters. In MLOps tools perspective, in AI, MLOps automates trainings, testings, and deployments. The equivalent of a kitchen analogy is the blender or a timer based oven or a dishwasher which automates the task. From an automation and scaling perspective, in AI, Kubernetes or Ray helps scale the workloads smoothly. Like when more guests arrive, helpers join in so orders don't pile up. The key takeaways in this AI technology architecture is the tools asset and the methods layer. It ensures that AI is not just powered by strong infrastructure but also has the right tools, frameworks, and automation to cook up a reliable, scalable, and useful applications. So think about AI technology architecture like the tools and the methods inside a kitchen. The cooking technique, which are baking, frying, grilling, are like AI frameworks such as TensorFlows or PyTorch. The waiters carrying the dishes are like APIs connecting AI models to other systems. The kitchen appliances like blender or the smart ovens are like the MLOps tools that automate and speed up the work. And when more guests arrives, extra kitchen staffs help scale operations just like Kubernetes or Ray scales up the AI workload. So with the right tools and methods, AI can reliably serve up value at scale. Core components of AI technology architecture. We have four aspects to cover: AI development frameworks, middleware and APIs, MLOps platforms, and emerging paradigms. The backbone of modern AI lies in flexible, extensible frameworks. TensorFlow. It's popular for deep learning, strong production integration. PyTorch is favored by researchers, widely adopted for production as well. Then you have JAX, which is high performance differentiable programming for research in large scale models. Then we have MXNet and Theano. These are early frameworks, now largely a legacy. Then we have Skykit Learns, which is widely used for classical machine learning. Enterprise often adopt a multi-framework strategy to prevent lock-ins and allow the right tools for the right task. Enterprise increasingly adopt a multi-framework strategy not just for technical feasibility but as a business safeguard. By avoiding dependency on a single vendor or platform, organizations reduce the risk of lock in, maintain negotiation power, and ensure resilience as the technology evolves. This approach enables leaders to apply the right tools for the right task, balancing innovation with cost efficiency, compliance, and risk management. This translates into future proofing investments, protecting agility, and ensuring that AI capabilities remain aligned with strategic objectives rather than dictated by vendor limitation. Middleware and APIs. Middleware bridges infrastructure with appliances or applications. We have the Open Neural Network Exchange, which enables models trained in one framework to run in another. Then you have API gateways, which manages AI microservices at scale. We have interoperability standards like REST or gRPC for service to service communication. Then we have model wrappers, which is packaged ML models as API, could be Flask, Fast API, or Torch Serve. A well designed middleware ensures that the AI services are portable, reusable, and composable. That is, well designed middleware is not just a technical convenience, it's a strategic enabler. By making AI services portable, reusable, and composable, it ensures that investments in AI can be scaled across the enterprise rather than confined to isolated projects. This portability protects against vendor dependency. The reusability reduces cost and duplication, and the composability accelerates innovation by allowing teams to assemble new solutions from proven components. This means that AI becomes a flexible enterprise asset, supporting faster time to value, lowering risk, and ensuring that the organization can adapt its AI capabilities as businesses' needs and regulatory landscape evolves. ML platform AI systems differs from traditional softwares due to model drifts, retraining, and data dependency. The MLOps platforms address this by integrating DevOps with ML lifecycle needs. At experimentation stage, we have ML flows, weights and biases, Neptune AI. At version control, you have the data version control or Git integration. At pipeline automation, you have Kubeflow pipelines, Airflows, and TFX. At model deployment, we have Selden Core and Bento ML. At monitoring, we have the Arize AI, Evidently AI for drift detection and fairness monitoring. MLOps is now considered mandatory in AI technology architecture, especially in regulated industries. MLOps or machine learning operations is the governance and the control framework that ensures AI models are not just built but safely deployed, continuously monitored, and responsibly managed. MLOps matters because it transforms AI from experimental projects into trustworthy enterprise assets. It enforces accountability, auditability, and compliance, which are critical in regulated industries, while also reducing risk of biases, model drift, or operational failures. In business terms, MLOps is the safeguard that ensures AI delivers consistent value at scale with transparency and controls that protect both the organization's reputation and its stakeholders. MLOps is no longer optional. It is the operational discipline that makes AI safe, reliable, and auditable, especially in the regulated industries. MLOps ensures that AI models are designed, tested, deployed, and monitored with the same rigor as financial systems or compliance control. It provides transparency into how models are built, traceability of data used, and accountability for outcomes. This means that AI is not a black box but a controlled, measurable, and governable asset. Embedding MLOps into AI technology architecture reduces the operational risk, ensures regulatory compliance, and builds the trust needed for AI to deliver sustained business values. Next is the emerging paradigms. The foundational model and generative AI. These are large language models like GPTs, Claude, LLAMA, and multimodal like for text, image, or audios. Requires orchestration framework like LangChain, haystacks, semantic kernels, etc. It introduces new layers of prompt engineering, fine tuning, and guardrails. We go deeper. Large language models or LLMs are not just advanced chatbots. They are enterprise scale engines of knowledge and automation. They can summarize complex information, generate insight, and enhance decision making across functions, right from customer service to compliance. But with their power comes the risk of bias, misinformation, data privacy, and regulatory scrutiny. The key is not in how the model works, but in how they are governed, secured, and aligned with the business objectives. LLM should be treated as high value assets capable of driving innovation and efficiency while being managed with the same rigor as financial or legal systems. If done right, they enable competitive advantage, and if done wrong, they would expose the organization to reputational, legal, and ethical risk. Orchestration. Orchestration frameworks are the control towers of AI operations. They ensure that data models and service work together seamlessly across the enterprise. This means AI is not just a collection of isolated projects, but a coordinated ecosystems where resources are optimized, risks are managed, and value is delivered faster. Orchestration provides visibility, consistency, and resilience, thus preventing duplication, reducing cost, and ensuring compliance. In strategic terms, it is what transforms AI from scattered innovation into a scalable, governed, and business aligned capabilities. Guardrails. Guardrails in AI are the safety mechanisms that keeps innovation on track. They ensure that AI systems operate within ethical, legal, and strategic boundaries, thus preventing misuse, bias, or unintended consequences. Guardrails provide confidence that AI will accelerate growth while protecting reputation, customers, and compliance obligations. Just as financial controls safeguard capital, AI guardrails safeguard trust. They are not about slowing innovations, they are about ensuring that every AI initiative is responsible, transparent, and aligned with the enterprise risk appetite and values. The next core component of technology architecture is AI agents and protocols. Protocols such as the model control protocol, or agent to agent protocol, or agent network protocol, or agent communication protocols are part of this. Agents can reason, act, and collaborate, moving beyond static models. Technology architecture must support agent orchestration, trust, and fail safes. Auto ML and low code AI. Tools like H2O AI or data robots and Google Auto ML democratized AI. It enables business analysts and domain experts to contribute to model development. AI technology architecture is the toolkit layer of AI. It includes the software frameworks, platforms, and tools that helps organization build, deploy, and manage AI effectively. The core component include AI frameworks and libraries, APIs and middleware, MLOps platforms, data processing tools, orchestration and scaling tools, monitoring and explainability tools. Let's go through it each. AI frameworks and libraries. These are tools for building and training the models, which include TensorFlow, PyTorch, or Scikit-learn. Examples, it's like cooking technique, baking, grilling, frying, each used for different recipes. At API and middleware level, you have connect AI models to apps and other systems. They are basically to connect the models across. Example, the waiters carrying food from kitchen to the dining hall. They are the bridging chefs and the customers. Then you have the MLOps platforms. They are used for automated model training, deployment, and monitoring. Here you have ML flows or Kube flows. It's like a smart oven or a dishwasher, automating repetitive kitchen tasks. Moving on, the data processing tools. These are tools to clean, transform, and prepare data. Here we have tools like Spark and Pandas. Example, it's like washing and chopping vegetables before cooking. Raw data isn't ready to use until it is clean. Then we come on to the orchestration and scaling tools. These manage workload across servers and scales the AI. These are your Kubernetes and Race. It's like adding extra chefs and assistant when the restaurant is full. Coming on to monitoring and explainability tools, these are used for tracking performance, detect bias, and explaining the AI decisions. Here you have shapes and line. It's like a head chef tasting the dish before they go out, checking for the quality and consistency. Key takeaways. The core component of AI technology architectures are like a kitchen tools, techniques, and appliances. The framework are your cooking methods. The APIs are your waiters. The ML ops are your smart appliances. Your data tools are your prepping ingredients. Your orchestration is kitchen staff's coordination. Monitoring is the head chef tasting each of that goes out of the kitchen. Without the kitchen, which is the AI systems, can't deliver consistent, high quality meals or application in our case. I hope this gives you a little better perspective on this aspect. So think of AI technology architecture like toolkit inside a kitchen. Cooking methods like baking or grilling are your AI frameworks such as TensorFlow and PyTorch. Waiters carrying food to the dining hall are like APIs connecting models to apps. Smart appliances like ovens or dishwashers are your MLOps tools, automating tasks. Your washing and chopping ingredient is like data processing, while extra chef helps scale during rush hour. That's orchestration. And finally, the head chef tasting dishes is like monitoring and explainability. Together, these tools make sure AI is consistently serving up the value. Integration with infrastructure. AI technology architecture must align tightly with infrastructure layer. Here you have the hardware accelerator, the edge deployment, the hybrid cloud, and data ops integration. Tensor RT for GPUs or ONNX runtime for optimized inference. This comes under the hardware acceleration aspect. TensorFlow Lite or PyTorch Mobile comes under the edge deployment space. APIs to seamlessly shift workload between on-prem and cloud comes under the hybrid cloud space. Streaming frameworks like Kafka or Spark feeding into AI pipelines comes under the data ops integration aspect. This integration ensures AI applications are not only built but are operational at enterprise scale. Optimized inference is about ensuring that the AI model deliver insight and decisions quickly, cost effectively, and at scale. This translates into two things: efficiency and trust. Efficiency because optimized inference lowers the compute and energy cost of running AI, making large scale adoption financially sustainable. Trust, because faster, more accurate output improves the customer experience, reduces operational risk, and supports compliance in regulated industries. In essence, optimized inference is what turns AI from an experimental tool into a scalable, reliable business capabilities that delivers measurable value without spiraling cost or risk. AI infrastructure is actually the hardware and the platform. These are servers, GPU, cloud, storage, networks, etc. The AI technology infrastructure are the software tools and methods, the frameworks, the APIs, MLOps, orchestration, etc. Integration means making sure the hardware and the software works together smoothly so AI can run efficiently, scale easily, and deliver value. Now, if you take an example of restaurant kitchen, infrastructure is the kitchen setup. The stoves, the oven, the fridge, the water supply, and electricity. Without these, nothing runs. Technology is the cooking tools and methods. The pots, the pan, the knives, the blenders, the cooking techniques. These turn raw ingredients into a meal. Integration is about kitchen and the tools working together. The blender plugs into the kitchen power, the oven uses both gas and electricity, the fridge connects to the water supply for ice. Now, if tools don't match the infrastructure, cooking becomes slow, unsafe, or impossible. Hence, in AI, if infrastructure provides GPU and cloud power, but the tech tools can't use them, or performance drops. If MLOps platform don't integrate with data storage, models can't be trained. Proper integration ensures seamless AI pipelines from data to applications. Key takeaways: AI technology and infrastructure must be like a well designed kitchen with perfectly matched tools. Infrastructure provides the foundation and power. Technology provides the method and tools. Integration ensures everything connects so the meal or the AI applications are prepared smoothly, quickly, and safely. In summary, think of AI like a restaurant kitchen. The kitchen setup, the stove, the oven, fridge is the infrastructure. The pots, the pan, the knives, and the blenders are the technology tools. For great meal, the two must work together. The blender needs power, the fridge needs water, and the oven needs both gas and electricity. It's the same with AI. If the software tool don't align with the hardware and the cloud setup, the system slows down or fails. But when technology and infrastructure integrate seamlessly, AI delivers smooth, fast, and valuable results. Let's look at some case studies. First is retail e-commerce. A global e-com player deploys MLOps pipeline with TensorFlow and Kubernetes. Automated training for customer behavior data. Real-time inference using TensorFlow service. It continuously retrains, thus reducing recommendation biases, and it results in uplifting of customer engagement. TensorFlow and Kubernetes may sound like technical jargons, but at a fundamental level, they represent the foundation for scalable enterprise grade AI. TensorFlow provides the framework to build and train the AI model, while Kubernetes ensures those models can be deployed, managed, and scaled reliably across the organization. Together, they enable AI to move from pilot project to production ready business solutions. This means reduced dependency on siloed systems, faster time to value, and the confidence that AI capabilities can grow with the enterprise. In strategic terms, TensorFlow and Kubernetes are the building blocks of a resilient AI ecosystems, ensuring innovation is not only possible but sustainable, secure, and compliant. Let's take a second case study. This is from the healthcare sector. A medical AI startup adopted ONNX runtime for cross framework model deployment. It trained its model in PyTorch deployed on TensorFlow Lite for mobile diagnostics. It enabled low cost, edge based inference in rural clinics. Result: expanded healthcare access without dependency on cloud compute. So, ONNX, which is the Open Neural Network Exchange, is not just another technical standard. At the foundational level, it represents interoperability and future proofing. ONNX allows AI model built in different framework to run across diverse platforms without being locked into a single vendor's ecosystem. For enterprise, this means flexibility, cost control, and reduced risk of obsolescence as AI landscape evolves. Strategically, ONNX protects investments, accelerates adoption, and ensures the organization can adapt quickly to new technologies while maintaining compliance and control. In short, ONNX is the bridge that keeps AI innovation open, portable, and aligned with long term business strategy. Case 3: Telecom fraud detection. A telecom provider integrates Kafka, PyTorch, and Kubeflow for streaming customer data usage via Kafka. Online learning models are trained continuously. Kubeflow pipelines, automated deployments are in play. Result: real time fraud detections are done within milliseconds. Now, Kafka, PyTorch, Kubeflow may seem deeply technical, but together they form the plumbing that makes enterprise AI possible at scale. Kafka enables the seamless movement of real time data, which is the lifeblood of AI. PyTorch provides the flexibility and speed to design, train advanced AI models widely used in innovation and research. Qflow ensures these models can be reliably deployed, managed, and governed across the enterprise. The significance is clear. These platforms prevent AI from being siloed experiments and instead make it a scalable, governed, and value generating enterprise capabilities. They reduce operational risk, accelerate innovation, and protect long term investments by ensuring AI systems are not only powerful but also manageable, auditable, and aligned with regulatory and business needs. In strategic terms, these are part of the unseen infrastructure that turns AI into a trusted enterprise grade asset. Let's look at challenges in AI technology architecture. We have five major. First is framework fragmentation, then we have vendor lock-ins, scalability bottlenecks, model monitoring gaps, ethical and regulatory complexity. Let's dive into it deeper. Multiple frameworks create integration complexity. It needs standardization through ONNX and API driven designs. This is part of the framework fragmentation challenge. Proprietary cloud AI services may limit portability. Hence, enterprise must insist on open source and open standard approach. This is the challenges that we have in terms of vendor lock-ins. Training versus inference optimization are often overlooked. Distributed training still requires fine-tuned orchestration. This is the bottleneck of scalability. Traditional DevOps tools are insufficient for AI lifecycle. It needs for specialized drift, bias, and explainability monitoring. That's from a monitoring gap in the models. Technology architecture must support audit trails, model cards, and explainability APIs. These are the ethical and regulatory complexity challenges that are experienced today. When organizations build AI technology architecture, they face challenges like too many tools and frameworks, integration gaps, MLOps complexity, scalability issues, skill shortages, security and compliance related challenges. Let's take a top view on each of them. From a tool and framework perspective, there are too many options, so it's hard to choose. It could be TensorFlow, PyTorch, JAX, etc. Each has its pros and cons, and not all integrate smoothly. When you come to integration gaps, the APIs and the middleware sometimes don't connect well with legacy systems. From an ML ops complexity perspective, automating model training, deployment, and monitoring are found to be tricky. From a scalability perspective, too many tools may work for small projects, or a tool might work for small projects, but will struggle with enterprise level demands. From a skill perspective, there is serious shortage of this at this point of time. Few people really understand AI framework and enterprise IT environment. Today we have more people understanding the IT environment at enterprise level, and many are trying to understand the AI framework. But to get skills who understand both equally well, there is a serious shortage. While this shortage will be there for some time, but it might be covered in next few weeks, months, years as we go. It improves with daily. From a security and compliance perspective, ensuring frameworks and tools meet privacy, frame fairness, and audit requirements are tough, extremely difficult. Now, let's take an example. Imagine trying to run a restaurant kitchen. Too many tools is like having too many gadgets. You have an air fryer, blender, steamer, oven, but don't know which one to use when. In AI, too many framework causes confusion. Then we have the blender plugs which do not fit into the socket, or the pan is too big for the stuff. Similarly, in AI, APIs or middleware don't fit into legacy IT systems. This is the integration gap. Now, in AI, too many frameworks can create fragmentation and confusion, turning innovation into complexity. For the enterprise, this means duplicated effort, higher cost, inconsistent result, and greater risk exposure. The danger is not technical, it is strategic. A scattered framework landscape weakens governance, slows the time to value, and increases dependency on niche skills or vendors. The solution is not fewer tools, but a clear architectural strategy that ensures that the right frameworks are chosen, standardized, and governed across the enterprise. This allows AI to be scalable, cost efficient, and risk managed rather than chaotic or wasteful. Moving forward, there are quite a few scenarios that we can discuss on. It is bank adopting an AI across functions. The fraud detection team builds the model using TensorFlow. The customer service division chooses PyTorch for its chatbots. The risk team experiments with Skykit Learns. Now, these are banks where different departments rush to adopt AI. Meanwhile, the IT operation group deploys pipeline using Kubeflows, while marketing uses Hugging Face transformers for personalization. Just think about the challenge that we have here. So, this is the challenge of having too many frameworks when things are not standardized. Now, the challenge here, different department adopting to rush AI. Now, because AI is the new baby, everyone wants to put their hands on, test it, experiment, or show that we are in the boat of AI. But in that enthusiasm, we mess up the whole scenario, a situation for the organization. So each team believes it picks the best tools, but the outcome is fragmentation. Models cannot be easily shared across or be reused across functions. Skills becomes siloed. Teams need separate expertise for each framework. Governance is harder as there is no single standard for monitoring, auditing, or compliance. The cost raises due to duplicated infrastructure and licensing. And when regulators come asking for model explainability, there is no unified process which exists. What was meant to be an AI driven advantage becomes operational chaos. Compliance risk and wasted investment stares at the board. The solution is not to restrict innovation, but to define an enterprise wide AI technology architecture where frameworks are standardized, integrated, and aligned with the business goals. Now, summarizing, picture a bank where each department picks its own framework. Tensor in fraud detection, PyTorch in customer service, Skykit learns in risk, Hugging Face in marketing. The result? Model can't be shared, skills are siloed, governance is inconsistent, and compliance is now a nightmare. So what was meant to be innovation turns into fragmentation, costing the organization much higher than anticipated, and regulatory risk is still staring hard on us. Now, the board's role is to push for a cohesive AI architecture so frameworks are standardized and aligned with the enterprise strategy. Imagining, we come back to the original one which we discussed, restaurant kitchen. The cooking, the plating, and delivering dishes smoothly is hard. Similarly, in AI, deploying and monitoring model end to end is a challenge. This is your MLOps complexity. The model works fine for 10 guests but collapses for when 200 arrives. Similarly, in AI, small tools break under enterprise wide workload. This is the scalability challenge. Moving on, fancy gadgets are useless if chefs don't know how to use them. Similarly, in AI, teams lack experts who can handle the framework properly. This is skill shortage. Now, if kitchen doesn't follow hygiene rules, customer would lose trust. Similarly, in AI, lack of fairness, explainability, and compliance creates a risk. This is the challenge that you have in security and compliance space. Key takeaways? Well, challenges in AI technology architectures are like running a modern kitchen with too many gadgets, mismatched tools, big crowd, and safety rules. Without careful choices or skilled chefs and clear processes, the kitchen or the AI systems could or would become chaotic. But when managed well, it consistently would produce safe, scalable, and valuable outcomes. Summarizing, building AI technology architecture is like running a modern kitchen. You got dozens of gadgets, could be blender, air fryer, oven, but it's confusing which one to use, just like too many AI frameworks. Some appliances don't fit the socket. That's your integration gap. It is easy to cook for 10 but impossible to cook for 200 or 2000 when the order arrives. That's the scalability issue. And without skilled chef, the fancy tool would sit idle. That's the AI skill gap. Finally, if the kitchen ignores the hygiene rules, the customer would lose trust. Just like AI must follow security and compliances. That's why getting the AI technology right is such a big challenge. I hope this helped you with some better perspective. Best practice. Adopt a multi framework strategy. You can use TensorFlow, PyTorch, and others as per your use cases. Implement ONX standards to ensure model portability across platforms. Operationalize with MLOps. Automate experimentation, deployment, and monitoring. Leverage cloud native design. Containerize AI workload for flexibility. Support edge and hybrid. Optimize inference for device and distributed environment. Build guardrails for Gen AI. Ensure prompt filtering, explainability, and misuse prevention. Let's look at strategic value of AI technology architecture. AI technology architecture provides enterprise with speed to market by faster prototyping and scaling, reduced complexity wherein middleware and API abstract hardware detail, operational resiliency, which is continuous monitoring, prevents failures. Built in explainability, auditability, and compliance ensure you are regulatory ready. Unlock new paradigms like AI agents and autonomous systems. This is your enabling for innovation. So, AI technology architecture isn't just about tools, it's about creating a structured, reliable, and scalable way to use AI so that AI delivery are real business value. They're not random experiment, but projects aligned with your strategy, your organization's goal. AI scales efficiently from one small model to enterprise wide adoption. AI builds trust through transparency, fairness, and compliance. AI increases speed and innovation by reusing tools, its frameworks, and the pipelines. AI reduces cost and risk by standardizing tools, avoiding duplication and chaos. If you take a we go back to the modular kitchen as a strategic asset. Okay. The business value is actually analogy is a clear menu. The kitchen isn't just cooking random dishes. It follows the menu that matches the restaurant's strategy. In AI, project follows the business goals. It could be fraud detection or customer insight. When we say scalability, the kitchen is designed to handle 10 guests or 200, scaling with staff and tools. Similarly, in AI, architecture follows a scaling model without rebuilding everything. When you come to the trust aspect, the customer trusts the restaurant because food safety and consistency are built in. Similarly, in AI governance, fairness and explainability builds trust. From a speed and innovation perspective, with ovens, mixers, preparation stations, the kitchen can innovate and deliver faster. Similarly, in AI frameworks, APIs and MLOps speed up AI delivery. The next is the cost and the risk reduction part. A well organized kitchen avoids waste and accidents. Similarly, in AI, standard tools reduces duplication and lowers the risk in the process. Key takeaway: the strategic value of AI technology architecture is like a modern restaurant kitchen. It ensures every dish is aligned with the menu and can scale for demand, also by maintaining trust through hygiene. They use smart tools for speed and avoid waste and chaos. It turns AI from a scattered experiment into a reliable engine for growth, trust, and innovation. So, in summary, if you say, think of AI technology architecture like a modern restaurant kitchen. The menu is the business strategy. The kitchen only cooks dish that matches it. Smart appliances and prep stations let chefs work faster. Just like AI frameworks and ML ops speed up innovation. The kitchen is built to serve 10 or 20, 200 guests, scaling as the demand grows. That's scalability. The hygiene rules keep the customers safe and trusting. Just like compliance and governance build trust in AI. With the right kitchen setup, every dish adds value. Similarly, with the right AI technology architecture, every project drives the business success. AI technology architecture builds upon the AI infrastructure base. We discussed this in the earliest part, providing frameworks, APIs, middleware, and MLOps platform that makes AI operational and scalable. It also incorporates emerging paradigms such as foundation model, AI agents, auto ML requiring enterprise to remain agile and future ready. By integrating infrastructure with technology, organizations establish the technical backbone needed to support AI applications at scale. In our next video, AI application architecture, we will focus on how AI is woven into business processes, services, and real world operations. So now we have come to the end of this part. We have looked at the introduction, the foundation, AI infrastructure architecture, now AI technology architecture. We will move with this agenda for the next video and the series. I hope this has brought in some value to the table. If it has, then do like, do subscribe so the next video when it's uploaded you get a notification. Do share it with any colleagues you think can benefit from these videos. The whole idea behind these videos is to help the community scale up and add value to the organization that you are representing. I thank you very much for the time you have invested till now. We are at the end of part 4. We'll see you in part 5. This is your host, Savit Vittal Salian. Namaskar.